Thank you for having me. First of all, I'm Alex. I mostly do audits and invariant testing on DeFi protocols, so my experience is going to be slightly biased to that end. And hopefully the tips are useful to you. So the first advice that I have is to think in bets. And I actually stole this. And it's based on the idea that everything you do, especially on a security engagement or in bug bounties, is a bet that is going to pay off. And as you explore code, as you explore combinations, as you think about the maximum impact that you can have, you want to effectively develop an intuition for what's going to work and what's going to fail. And you want to be, just like with investing, you want to have strong opinion, loosely held. Because fundamentally, you don't know where the bugs are. Your time is limited. Your attention is limited. And as such, you want to prioritize based on either a maximum impact or a maximum gain or a maximum benefit to your customer. And at the same time, you also want to establish or remind yourself how confident you are on certain areas of the code base. And therefore, this idea of thinking in bets applies both in prioritizing what code you're gonna look at, and then it's also about self-assessing how confident you are that a piece of code is safe, or how confident you are that you should go and take a second look. In a similar fashion, as you expand your understanding of the code base, while you effectively selectively ignore parts of the code, because again, prioritize and ignore, you also want to constrain behavior, which is the idea that you don't necessarily want to look at all possibilities that the code can have. You want to instead, as you look at each line, as you look at each component, you want to effectively simplify it down to the most logical combinations, as well as the most interesting edge cases. And this is something that I'm going to talk about at the main event as well on Thursday, so definitely be there. But it's really the idea that as humans, we are particularly good at finding heuristics or simplifications that allow us not to have to focus on the entirety of the code base. And so that's something you want to keep in mind is once you're done with some piece of code, you literally express the constraint in some way, and now you just ignore it. And that way, you don't have to think about it anymore. You just think about the combinations that you'll have off of the code that you reviewed. This is a really good advice that keeps popping up on Twitter. It applies especially to contests, and it's that most people find the same piece of code hard, and so it's like if it's hard for you, it's hard for everybody else. I'm doing a small mastermind group with a bunch of white hats, and it's always funny to me that like half of those people, they always choose the same contest. Like I'm sure you know there's like 10 to 15 contests running at all times, and yet half of the people always choose the same one. And I think it's really because of this idea that if it's easy for you, you're more likely to do it, and if it's hard for everyone, then for you, it's probably hard for everybody else, so nobody does it. So keep that in mind that you really want to have to kind of fight your own biases, and you want to effectively understand that more opportunity is where is in the path least traveled effectively. And another great advice is to seek truth. So fundamentally, when you're performing a security review or you're understanding what the developers are trying to do, you want to understand that you're biased towards, for example, trusting the developer or trusting your own biases. But fundamentally, as you perform a review, you're just seeking the actual truth of what the code does. And so the closer you are to objective reality, which is effective math, the closer you are to the math and the truth of it, the better you're going to be at your job. In a similar line, you want to understand a system first and then break it. I like to call it the smash and grab versus kind of the systematic attack. Smash and grab is the idea that there's a bunch of low-hanging fruits in the code, rounding error, Oracle staleness, that type of stuff. Everybody can find it, and it's really not particularly unique. And hopefully we'll get rid of all those bugs one day through automation. But most interesting bugs and most important bugs are found by first understanding the system, then having kind of a detached perspective, kind of a thinking, just yourself, you want to basically think about the system, and then you're going to kind of find these new paths. It's like you kind of unlock the those bugs because you understand the system first. And something that I want to emphasize is that building is harder than breaking. It's very crucial that you keep that in mind, because a common mental pattern, especially for red side hacking, so to basically steal money, is fundamentally that you don't want to have respect for the developer. And I think it's a good mindset to have in practice, is to believe that the developer can make mistakes and you can, kind of beat them in a sense. But you also want to keep in mind that if the developer is all unsuccessful, you will never have a job. So fundamentally, you want to make sure that developers are successful, and you want to understand that it takes not only a ton of courage, but also a ton of research and a ton of work to actually build something. And this is also why most great DeFi protocols tend to be very elegant and tend to be very simple. And it's really because it's so easy to write crappy code, but it's very difficult to write something that will actually last. So keep that kind of respect in mind as you fundamentally disrespect their work and you do your job, but keep it in mind that these people are putting themselves out there, and they deserve a lot of respect for doing that. So this is kind of a hot take. But I like to think of tools as a substitute for thinking. And so the key idea is that when you're dealing with some sort of a math-heavy piece of code, or you're dealing with something you don't fully understand, you actually can use tools to do the thinking for you. A good example that I have is whenever I'm looking at a function, I like to just build like a quick Python script to build me a graph. And that's because even if I don't fully understand the math, now I can quickly see it, and that can help me think about what the code is actually doing without having to be bogged down by the details. So I don't advocate for using tools at all times, but I believe that a smart researcher knows when something is above their pay grade or something is above their skill level, and tools can help you kind of get up, kind of cheat a bit and get up to that level, and possibly find bugs that you can't find through reasoning or math alone due to your skills. Something else that I wanna, this piece of advice comes from the Rari Capital hack, where a low severity fix caused $80 million being stolen. And so a fully understood low severity bug is always better than an untested fix. This is something that I heavily advocate, and it's the key idea that once you understand a system and its limitations, then you can work around it. Whereas if you try to forcefully fix those limitations, and another great example is the dust balances on Euler V1, you end up introducing critical bugs because the amount of effort that it takes to constraint behavior, to do the audit, to reduce the risk, is completely thrown away when you introduce a fix that doesn't go through that same process. So fully understood the low severity is always better than an untested fix. And this should lead us to the next insight, which is if it's not tested, it's always broken. I've yet to see, and I've worked with extremely smart people, and I would consider myself a somewhat productive developer, but I've yet to see anybody in DeFi ever be able to ship a safe project with 0 tests. I've never seen that. I tried myself, but I wasn't able to. And so this is a key insight that tests can reveal the maturity of the code base, and test or your self-writing test can also help you understand the system better. And so this is like a maxim whenever you're working with a set of developers. If they don't even speak the lingo of tests, in the sense they don't even think about coverage, and obviously there's more to that. There's modified decision and condition coverage. There's other more advanced ideas we can talk about, but fundamentally, if you or your developers didn't put in enough effort to know that the system works properly, it doesn't work properly. There is 0% chance. So keep this in mind. Another interesting idea that I keep changing my thoughts on, but currently, is to think of AI as a brainstorming tool. AI is an incredibly good tool for the end user because it does all the work, and if the bug is valid, it's done. So it's beautiful when it works, but when it doesn't work, it's basically worse than Slither. And I hope some of you resonates with that, because it's basically just a pile of stuff that was looked at that contains mistakes and that is not particularly actionable. And so the way I like to use AI is very different. Is when I'm done in my review, when I have no thoughts left, when I like all the options are explored, that's when I need the insane hallucinations of the AI to give me new ideas, because that's a great way for you to just be a bit more imaginative. Something I learned, I think it's an interview question from an hedge fund, or maybe it was Einstein, I don't remember exactly, but basically there was this interview question where they will give you a theorem, like some math, and then they will tell you, what if this constraint of physics was no longer there? And you would actually find that the smartest people will start to kind of think of new ways. And that's the same thing you can do with code, where you can basically eliminate a constraint, and from there you can you will basically find new bugs. And then your only problem is to find a bypass to that one constraint, which is a pretty cool way to find very unique bugs. Another key concept tied to thinking in bats is working with progressive escalation, which is the idea that you should do the least work that is necessary to break a system. So if you can do it by reading the code and you find a bug, great, write the POC, be done with it. If you need to write it on paper, talk to Claude to figure out the math, go ahead and do that. If you need to fuzz it, go ahead and do that. If you need to formally verify the entire system before you can find the bug, do that. However, we're limited in our time, and we have to think in bats. As such, we want to work with progressive escalation. So if you have more tools, you want to create your own internal ranking of complexity and effort, and you want to decide when to apply each, with the full understanding that the only way to be 100% certain, or at least to be 100% done in your process, will be to actually do everything in all cases, but that's obviously impossible. So keep in mind that you don't have to do all of the work. You can find the easiest way to get to a bug and then be done. And a really cool idea of on being average is that if you are an average security researcher, your life and your I guess your income is going to be much higher than if you are the average I don't know, bricklayer or taxi driver. And so understanding the meaning of being average really means that you want to look at your peers. You want to find peers that inspire you, or peers that have, let's say, the lifestyle that you want. And you can be an average researcher at that level, and you're still going to have a really successful life. So don't worry if you're not, the number one on the leaderboard. I know, I wish I was. Obviously, everybody wishes they were, winning everything. But understand that being average doesn't mean, it doesn't actually suck that much. So try to get to average, then find your base, and hopefully one day we'll see you at the top of the leaderboard as well. So another really cool insight from this year is that you can very cheaply and very quickly formally verify stateless libraries and extract constraints. So this is very technical, but it fundamentally means that you can write a couple of tests. You can use the Certora Approver, you can use Almos or Control. We use them all and we like them all. But basically you can take some logic from a system, put it in a library that has zero state, and that basically means that these tools will very quickly prove a bunch of stuff. They will prove whether the math is sound, and you can likely also quickly optimize the bounds and basically get a bunch of maximum and minimums from it, which means that once you're done with that, you can simplify the system in your head, and you no longer have to even look at all of that code. So this is something we advise to all developers we work with, is just put all of the nasty logic in a stateless library, remove the state, so that we can formally verify it, even if it's massively complex, and it's really easy to do. But at the same time, there are no easy paths, I guess. You just have to get better. This is something that I learned, and you can look at my audit report from Liquidity V2 from Bold. But something that I learned is you have to rise to the type of challenges that you're faced. And so if you, for example, are unable to exploit, I don't know, rounding errors, you're unable to work with certain code bases, it's an indicator that there's no easy path. You just have to improve on that. And most of the times, that comes from an extended amount of time in which you focus, and then it comes from putting a lot of effort into it. So what I can say from my experience, though, is that anytime I do something intellectually hard, I think my brain permanently changes. So I think that type of learning is something that you want to give to yourself, and it's something that sticks there. So my advice is really, when you're faced with something difficult, keep at it, because it's not going to get easier, but you're going to get better, and those benefits stay forever. So understanding when to clamp and when not to is an idea that sometimes you can just simplify the system, just quickly put some numbers in the system, and it's likely going to represent all the cases. So there are many times in which you can be very greedy with simplifying code or simplifying the system as you think about it, and you basically explore all the meaningful combinations anyway. So most of the times, you don't have to overcomplicate your thinking on some code. Another idea to instead create a ton of work for you is to rewrite the code and compare nodes. So you would read, let's say, a vault, you would read like some sort of system, and then you read all the documentation, you're like, okay, I fully understand it, and then from there you will basically rewrite it, and in rewriting it you will identify issues in thinking that the developer may have, and the other thing you'll find is if you could have written in a much cleaner, much more elegant way. Both of these lead you to bugs and lead you to also being a better researcher in general. And a pretty interesting idea is that peak experiences are like a wave. So you will likely find some amazing bug, but it will come at a price. And so you don't want to ask yourself to always be at the top. You can't always be on the top of your game. You want to instead prepare for the peak experience. You want to enjoy, you want to ride the wave, but then you also want to take time to rest. And you really want to embrace this idea. If you look at great entrepreneurs, they have a bunch of money, they rest until they find a great idea, and that's when they go all in. There's really no point in being all in all the time if it's not worth it. So instead, try and find the wave that you want to ride, and then hold on to that for dear life. Similar idea, most contest winners have a brutal track record. I really respect Zigtur, but at the same time, if you look at his Cantina page, you will see that there's the valley of death of $0, $100, $1,000 results, and that's where most people quit. And so keep in mind that to get to that peak experience, there was a lot of effort, and there was a lot of, he basically created his own opportunity to have those peak experiences. And it's easy to just look at that, but to forget what it actually took, which is, I think it was an extremely brutal track record. There's totally random, and there's really no rush in writing a report or a POC. Just write it slowly over time and make sure it's simple and it's clear. Don't use any tricks there. Just write it slowly until somebody else can understand it. In a similar note, it's always a serious deal or just don't bother. Don't half-ass your reports. Don't half-ass your bounties. Don't send the low quality, low effort bug because you don't want to put in more work. Either do it really well or don't bother, because people will find a way not to pay you. So you may as well just do it well. And start with the end in mind, which is really the idea that if you're finding bugs and you're writing reports, start early in doing that, in setting yourself up for success. You don't have to have this separate phase, etc. You can instead think about what your end goal is, and you progressively get to it instead of separating into very harsh steps. I'm going to very quickly finish my points. Always read code, and when you can't read the code anymore, that's when you try something else. That's when I will start developing, only when I'm really tired.
and you really don't understand how hard it is to actually review code at the highest level, find the best person you can, work with them for a day. It will change your life. I know it works from experience. If you're done before an audit, it means you're not even trying. Nobody's ever done in an audit. If you're done, it means you're literally not even playing the same game. Understand your edge and use it to your advantage is the idea that you want to, over time, build a deep set of knowledge on a specific set of protocols, and you want to push that as much as you can. Or if you have a unique bug, or if you have a unique technique, push really hard. There really is no overnight success. It's really the world catching up to you because of the efforts. And you just want to really repeat those basic foundational steps consistently. My favorite thing is to find people I really respect and learn from them, whether by hanging out or just looking at the research. There's a ton of very brilliant people here, really inspiring people, and you just have to find them and model them. And then forge your own path. Fundamentally, there is no right or wrong way. You have to live with the consequences of your decision, so just forge your own path. Learn from reading common bugs, but then create your own category defining bugs. Resting is work, which means that, as I said, you want to give time to yourself to grow, and the growth happens in resting, just like in the gym. Be careful about your own biases, because you will eventually start missing the same type of bug, so you have to self-correct, and the only constant is you. So believe in yourself, keep going, and let me give it up for Rajiv next.